Hi. Here in this problem, we would like to find the effective resistance between the points A and B. You can see what is given is there is a resistance 2 ohms, 6 ohms, 6 ohms, 6 ohms, 2 ohms. But you can see a line here. This is the line. This is a straight line, which means these are short circuited. These 2 points are short circuited, directly connected with each other. That means what? This point and this point are the same. They are not different. Similarly, you can see the same here also on the top. This is a short circuit. That means the 2 points are connected to the same wire. That means this point and this point are same. That's a basic thing that you need to understand. Once if you understand, you can redraw the circuit, the equivalent circuit of the above circuit as, I'll keep the A as it is. There is a 2 ohms at the A. Notice, here is a point P, this point P. From P, there is a point P. From P to Q, there is between point P and Q, there is a resistance of 6 ohms. So let me draw that. 6 ohms. So what I am referring right now is this resistance. So just for reference, if I call this resistance as X, this is this 6 ohms X that we are referring here. Now look a little bit carefully once again. This 6 ohms, this is also between the points P and Q. That means what? Again, between the points P and Q, there is not only one resistance X, there is another resistance Y. So I shall draw another resistance 6 ohms, which is actually Y in the diagram. Now look for that. There is another 6 ohms, this resistance, which is also between the points P and Q. That means what? In the diagram again, between the points P and Q, I shall draw another 6 ohms, which if I refer it like Z, this is whatever Z is. So what you can see in the diagram is between the points P and Q, there is one resistance here, there is one more resistance here, there is one more resistance here. There altogether there are 3 resistances are there. And then after the point Q, what we can regularly see is between the Q points, so this will become the point Q, obviously. Between the Q and B, there is another 2 ohms. There is another 2 ohms. This is the point B. Now, what we can observe is this 6 ohms, this 6 ohms and this 6 ohms are in parallel. We know when the resistances are in parallel, we have a formula 1 by R parallel equal to 1 by R1 plus 1 by R2 plus 1 by R3. All of them are actually equal in this problem, 1 by 6 plus 1 by 6 plus 1 by 6. That means the 1 by R parallel is 6 is the LCM, 1 plus 1 plus 1 is 3, that is 1 by 2. So if you simplify that equation further, 1 by R parallel is 1 by 2, therefore R parallel equal to 2 ohms. So if you redraw the circuit, this is A, 2 ohms, this is the point P, this is the point Q. The resistance between the points P and Q is a combination of 3 resistors, 6, 6 and 6 in parallel, and their equivalent value is 2 ohms. Of course, between Q to B, there is another 2 ohms. Now we can see between the RAB, there are 3 resistors in series. You know, in R series, resistance, equivalent resistance is R1 plus R2 plus R3. That is 2 plus 2 plus 2. That is 6 ohms. And B is actually 6 ohms. This is how we have to solve this kind of problems. So the thing that you need to be careful about is this kind of a connection. This is called short circuit. If a straight line is given, that is called short circuit, and the points of the short circuit at the starting and ending are same, right? Thank you.